Hello, happy physics people. I am here to talk about one more practice puzzle that we have been working on with circuits. We are going to solve this one. There's 1, 2, 3, 4 resistors, and you can see them numbered here. And we are going to solve this one using a VIR chart. As you remember, Ohm's law says that the change in voltage is equal to the current multiplied by the resistance. And so this is a nice little way to organize the information that we have, knowing that the voltage will be the product of these two columns. So we'll go ahead and get started. This circuit, we know a number of things. We start off knowing the voltage in the battery, which we call the total voltage. So I'm going to fill that in here. We also know the current that's coming up here, 8.5 amps, and that's the current, if we follow it along, that's going to be flowing through the battery. And so that's our total current. We can fill that in, that's going to be 8.5 amps. All right, resistor 1, we know has a resistance of 5 ohms, so I'm going to put that up here in our row for resistor 1. Resistor 2, we actually don't know any information about. We don't know the current, we don't know the resistance, nothing about that, so we're going to have to leave that row completely blank. All right, row 3 is for resistor 3, that has a resistance of 2 ohms. Resistor 4 has a resistance of 6 ohms, and then I added a row down here for the combined resistors 3 and 4 since they're in a branch in series together. And we'll get back to that in just a few moments. All right, as always, I think it's nice to start where you have the most information. So if we look at this total row, we know the voltage is going to be equal to the current, 8.5, multiplied by the resistance. So to find the total resistance of our circuit, we just have to do a little bit of division here. We do 20 divided by 8.5, and we get this nice number, 2.35. And we can leave that there. And that's the total resistance once we have all of this nailed down. All right, well that doesn't really help us solve the rest of this. So let's look at what else we know. It's always nice to start off with Kirchhoff's rule. So if we look at the loop rule, as I'm going around this smaller loop, what I can tell, I know this current isn't going to be going through here because it's going to have split off first, but around this small loop, I know how much voltage I'm gaining. I'm gaining 20 volts, and on the small loop, there's only one resistor over which we're losing that. So resistor 1 has to use up all 20 volts from the battery for the current that's going around that loop. All right, now that gives me a row that I can add some more things to. So 20 is the current times 5. So I can do that division without a calculator. 20 divided by 5 is going to give me 4 amps for the current. All right, and I'm going to go ahead and draw that in here, 4 amps. Okay. So we know we have 4 amps. It's going to be meeting up with another current here and going up to 8.5 amps, going back through the battery. But the same logic that we used here to say that that was 20 volts, we can also use around here. If we look at this slightly larger loop, the loop that goes through resistor 2, it also has just the battery and the resistor on it before we get back to where we started. So if we're gaining 20 volts over the battery, that means we're losing 20 volts over resistor 2. So now we finally have something in that column. Not enough to calculate the other two though. All right. Now is where I'm going to use this bottom row because I can do the same logic. I can say, well, we've gained 20 volts here. We're going to lose 20 volts during the course of resistors 3 and 4 together. Not over each individually, because that would mean we lose 40 volts, but together they take up 20 volts. Now, the resistances are not the same, 2 ohms and 6 ohms, so we know it's not going to be exactly divided equally, 10 and 10. In fact, we can guess that probably the 6 ohm resistor is going to use up more energy than the 2 ohm resistor. But we'll come back to that. All right, the other thing we know, we have resistors 3 and 4, and they're in series here, one right after the other. And remember, the equivalent resistance for resistors in series we can find by simply adding those two resistances together. 2 ohms plus 6 ohms. And that's going to give me 8 ohms in this resistance. All right, now when we look at that, now we know everything in this row, this 3 and 4 row, except for the current. So we can say 20 is equal to I times 8, which means to find I, we just do 20 divided by 8, and we get a current in that branch of 2.5 amps. Okay, so I'm going to add that in here as well. that current is 2.5 amps. Squeezing our amps there. All right. Now, as I'm looking at the current, I'm noticing something interesting. We have kind of three branches of our circuit, the branch with resistor 1, the branch with resistor 2, and then the branch with 3 and 4, and they all come together to give us a total current of 8.5 amps. We've accounted for 4 here and 2.5 here, so that's 6.5 of our 8.5 amps. That means the other 2 amps have to be coming from this branch of our circuit, right? This has to be 2 amps if that's going to add up to 8.5. And that's Kirchhoff's junction rule, that the current coming in has to be equal to the current going out. So this is going to have 2 amps flowing this direction. And so I'm going to fill that in. Here we have 2 amps. I'm going to put that under this column. That means that I can fill out this row. I can say that 20 divided by 2 is going to give me a resistance here of 10. All right, 2 more boxes to go. And these are going back to this larger loop where we have resistors 3 and 4. All right, we figured out that the current passing through these resistors is 2.5, and that's going to be the current that's passing through each one of the resistors. So I can actually fill in here 2.5 for both of these values, since that's the current flowing through each one. Right, we can do a little multiplication, since V is equal to I multiplied by R. 2.5 times 2 is 5. 2.5 times 6 is going to give me 15. And then we can double check that math by saying, well, if we gained 20 volts when we went over the battery, that means we're going to have to lose 20 volts here, and we're losing 5 and then 15, so that sounds like 20 before we come back to where we started. All right, if we also look at the way the resistances are using the current, you know, we usually talk about the current, more of the current flowing through the path of least resistance. So if we look at our resistors here, we have a resistor of 5 ohms, a resistor of 10 ohms, and then a resistance combined of 8. And so if we look, we actually can look and see, yes, we do have the most current going through where we have the least resistance, and we have the least current going through here where we have a 10 ohm resistance as opposed to the 8 and the 5. And so that all is making sense. And now we have all of the information that we need to complete our circuit diagram.